Bismillahirrahmanirrahim. Welcome to my channel, Learn Math with Syed Ali. So, we will be continuing our topic, exponential function. And the basic exponential function is y is equals to a to the power x. And the transformed function is with multiple variables, which is c times a to the power k times x plus b plus d. So we have to determine these extra variables, what are the values and what are the effect of these extra variables when we come to the transformation. So we have to answer the few questions like the same as we did in the previous example. So this time I have a function, for example, y is equals to 2 to the power x and is transformed to y is equals to minus 3 times 2 to the power x. So it's transformed to this. And if we see the whole transformation equation, that means we can see that c is equals to minus 3. So in this equation, I can say that c is equals to minus 3, right? And what else? What I can determine here? So c is my c is minus 3 and my a is 2, right? My a is 2. So I will say a is 2. And what else I can see here? And my d is 0, right? Because there is no d. D is 0. And x plus p, my p is nothing. So p value always give me the horizontal transformation, right? Horizontal transformation. So there is a reflection, but in this case, what the reflection? You can see that horizontal reflection sine of k. What is sine of k? Is there any k? So my k value, do I have k here? So my k value is a to the power k, right? A to the power k. So x, a to the power x, right? So I have no k. So I have to see what are my same values, right? I have to write down the domain, I have to write down the range in the notation form, and I have to select what my exponential function has: growth, decay, or stabilization, right? So this is my value of a. What is my value of a? A is greater than 1. So here is a is greater than 1. What is my a? A is minus 3. Oh, a is 2. Sorry, a is 2, right? A is 2. So so I have to see what if a is 2, but there is another thing which we need to see. A is 2. Supposing that a is 2, so we are seeing, oh, a is 2 greater than this, so this is a growth. No, but we have to see at the same time c and k, right? If c and k have the same sign, right? K is plus 1, right? K is nothing, right? So we say that is plus 1. So if k and c has got the same sign, we say that it is a decaying function. It is a decaying function. So we say that, okay, it is decaying. So I will say here a is equals to 2, right? And my horizontal asymptote will be horizontal asymptote will be y is equals to 0. Y is equals to 0 because is y is equals to d, and d is nothing, right? So d is 0. I can see that here it is plus 0, right? So y is equals to 0 is my horizontal asymptote. And what this function is growing or decaying, right? That depends on value of a. But having here the value of a as 2, so we are saying that, oh, it is 2, right? But this function is decaying. Why it's decaying? If I have a value of tables like x and y, I can easily determine that it is decaying, because if I put 0, x 0, right? So it comes out as minus 3. If we solve this function, 2 to the power 0 is 1, so minus 3, right? If I have x 1, then I have this 2. 2 times 3 is minus 6. So its value of y is going down. So this function is decaying. So 2 or decreasing. So 2 to the power of 2, 4, 4 3 is 12. So this function is decreasing. So that's why not only the value of a which is greater or in between a, there is another thing that if c and k are opposite, if c and k are opposite, so c is minus 3 and k is plus 1. If c and k are opposite, it's always decaying. So the function is decaying. So I will write function is decaying or decreasing. And I have shown you the value of table as well. So that means that this function is decaying, right? Next, what I can find out? I can find out the domain using the notation. So domain is always easy because domain is all x values, and x values is such that x belongs to R. We give any value to x as we did here, 1, 0, 1, 2, 3, and so on and so forth. We can go on. And then the fourth one is, so this was my third one, and then my fourth one is range. I have to write down the range, right, in notation form, and that will be x such that, y, range is always y value, so y such that y is less than 0, right? So y is less than 0, c is negative. See here, y is less than d when c is negative, and my c is negative here. My c is negative. C is the coefficient before a, right? So c is minus 3. So this thing is telling me that my y is my range, y such that y is less than 0 and y belongs to R, right? Y is less than d and d is 0, right? So everything is from my data. What is transformed equation? My transformed equation is this, and my data is here. What is C, what is A, what is D, what is P, and what is K value. So now my range is done. Lastly, I have to state the transformation. So number 5 is horizontal transformation, and horizontal transformation I have to tell R, S, and T, right? The value of R is the value of K, the sign of K, right? And there is no K, so there is nothing to worry about horizontal reflection. There is no value of K, so there is no stretch, right? And there is no P value, right? No P value, no value, you can see. So we have nothing to worry about, none, right? Horizontally, there is no transformation. Now we have to see vertical transformation. So number 6, if we see the vertical transformation, sometimes we do it separately, sometimes we do number 6, next number. So it depends how the question is asking you. So now vertical transformation is again RST. Here now this time the vertical transformation, we have R, S, and T, and that depends on value, right? Which value? Value of C. What is value of C? C is minus 3. So that means vertically we have the reflection. This is sine, right? So we have reflection because of negative sign. Here we can see sine. R is sine of C. So what is sine of C? Sine of C is negative. Therefore, we have the reflection. Stretch of 3 because the value is there. It's vertical stretch, S-T-R-E-T-C-H, stretch of 3. And what is the last one? Last one is nothing because it is dependent on the value of D. There is no value of D. So there is no T, right? So RST, you have to see everything with the variables which you have in your exponential equation. And then number 7 is how to draw this graph, right? So we have everything. We can draw the sketch now. So if we have the table, we have the reflections, we can draw it. So what is my x value? X value is 0. Then we have minus 3, 1, 2, 3. So here, I am here. And then my 1 is minus 6, 1, 2, 3, 4, 5, 6. So I am somewhere here. And then my 2 is 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It goes like this, right? And here it is like this because y is equals to what my equation is, y is equals to 0, right? Y is equals to 0 is my horizontal asymptote, right? It's approaching to y, but never approach to y, but it's approaching to y, and it's decaying in this fashion, right? So the exponential graph is decaying in this way. So I have my values, right? So y is equals to 0 is my asymptote, right? It's going this way. Y is equal to 0 is my x-axis, right? So it's going parallel to, kind of parallel to x-axis, is the asymptote. Y is equals to 0, and it is going to decay because it is decreasing. Y value is decreasing. So I have everything with the help of these green things, what I have wrote here. So all values are dependent or can be selected depending on the A is the growth, decay, or stabilize. But if we have C and K same sign, that is the second thing. Sometimes we have A is greater than 0, but we have C and K the same sign, right? Or C and K are the opposite sign. Whenever C and K is the opposite sign, although here we have A is, value of A is, what is my value of A? Is 2. So somebody can say, oh, it's growth. But no, we have to see the second term as well. Second term will be valid. If second term is valid, we have to see the second term. C and K are opposite, so it's a decaying function. So I say function is decaying or decreasing. You can see that function is decreasing, right? And then domain and the range. Then we have to see the horizontal transformation and vertical transformation. Horizontal transformation of the exponential function is dependent on value of k and sign of k. Sign of k is negative, then it is reflection in horizontal. If positive, nothing, right? No reflection. If value of k is there, then we put that value of k that is stretched by that value. Value of p tells us the traverse, like the horizontal travel. Horizontal travel means left or right. So if we have the p value positive, right? So plus or minus is our travel on the x-axis, horizontal. And then vertical transformation depending on, right, r is the on the value of c, sign of c. If sign of c is there, negative, then it is down. If c is positive, then it is up. Then we have stretch. Stretch is the value of c. So whatever the value of c, that is the stretch value. And then if it is moving up and down, that depends upon value of d. If we have the value of d factor, here 0. So there is no sign of vertical transformation, like there is no vertical transformation, right? There is no horizontal transformation, right? So there is nothing horizontal to worry, but there was reflection in vertical, right? And there is a stretch of 3, right? And then we did the graph of this exponential function. The parent function was 2 to the power x, and the transform function was minus 3 times 2 to the power x. And we determine our values c, a, d, p, and k depending on this transformation, which is the full transformation of a exponential function. So we learn here again the same thing. We will have more example to deal with this situation, and we will get to the point that by seeing the transformed equation of a exponential function, we can draw the graph immediately because we know which way it's going. So hope you like the video. If you like it, press the bell icon button to receive another video. Thank you for watching.